Section 1.9 is called opposites and absolute values. And before getting into those things, let's take a look at the number line. So there's a couple different definitions of number line. The first one is that it's the graphs of the real numbers, and graphs means the points. So the number line is just all the real numbers graphed. So it's a whole series of points. It's not just these integers, the positive and negative integers. It's pi, it's all the rational numbers, it's all the irrational numbers. You just can't show them all or label them all on there. And the symbol here, which is a capital R, and it has an extra little line here is the symbol for real numbers. You could also say that the number line is a set of paired opposites. That's kind of a second definition. And that means that if you take any number on the number line, it has an opposite. So for example, the number 1 has an opposite of -1, and -1 has the opposite of 1. So every number has an opposite that pairs with it on the number line, and the set of all these paired opposites forms the number line. So 3 has the opposite of -3, and -3 is the opposite of 3, and that's one pair. Even pi and negative pi is an opposite pair too. So all the numbers and their opposites makes up the number line. Now the reason for going over the number line is that in order to understand absolute value, you have to have some idea what the number line is. So the absolute value is the distance between the graph of a number and the origin. So if I want to know the absolute value of 2, that's going to be the distance from 2 to 0. So that's 2 units. And so the absolute value of 2 is 2. Now if I look at the opposite of 2, -2, it's also 2 units from 0. So the absolute value, the distance, it's still 2 steps. It doesn't matter whether you're going right or left. It's still 2. So the absolute value of -2 is also 2. The absolute value of -4 is 4 because this point is 4 units from 0. The absolute value of +4 is still 4 because it's 4 units from 0. So that's kind of the mathematical definition of absolute value. Now in opposites, we talked about a little bit in terms of the number line, but a negative sign is used to show opposite in algebra. And a negative sign can be translated as the opposite of. You could read it that way. It's the opposite of. -4 means the opposite of 4. Well, that equals -4. And if you have -4, that means the opposite of -4, which equals a +4. And that's why when you have 2 negative signs right next to each other, it equals a positive because it's the opposite of a negative. Example 1, -5 plus 3. So solving the inside of the grouping symbol first gives you 8. The opposite of 8 is a -8. Example 2, -1.3 means the opposite of -1.3, which is a +1.3. Or you could just know that 2 negatives cancel out and make a positive. Now some absolute value examples. The absolute value of 3. Whatever's inside the absolute value symbol is going to come out to be positive. So if the number inside is positive, it doesn't change. It comes out as a positive. If the number inside is negative, it comes out as a positive. And 0 is neither positive nor negative. So the absolute value of it is just 0. So you could think of the absolute value symbol, first of all, it's a grouping symbol. You can think of it as being a washing machine. So a positive number would be like a clean number and a negative number would be like a dirty number. So if you put in a positive or a clean number, it's not really going to do anything. It's still going to be clean when it comes out of the wash. But if you put in a negative number, which is a dirty number, it's going to get cleaned and come out to be a positive. One more one more example under example 3. If you have a negative sign on the outside of the absolute value, that isn't affected by the absolute value. So I have to do what's inside this grouping symbol first. And this becomes positive 2. This is carried over then. So you have opposite of positive 2, which is a negative 2. Now I'm going to stop. Let's see, I'm going to rework these problems separately here. So let me pull this off. All right, let's do, now this is a little different. How do you solve for x? And let's do, so this will be example 4. If I have the absolute value of x equals 3, now this is different from example 3 because before we had numbers inside the absolute value symbol, which is just makes it easy to figure out, but we have a variable inside. So when you solve this, you have to figure out what values of x will make a positive 3 come out. Well, we know 3, obviously, the absolute value of 3 would work here, but there's another solution too. Negative 3 also works because the absolute value of negative 3 is also positive 3. So the way to write 3 and negative 3 is like this. You put a plus minus 3, which means 3 and negative 3. Then to check this one's really easy, but I'll plug in a 3. And yes, 3 equals 3. Then plug in the negative 3. And that really equals 3. So that checks out. When you solve equations that are that have an absolute value on one side, what you really are doing is taking off the absolute value sign, and then you have to add a plus and a minus on the opposite side of the equation. So let me show you with another one. Example 5. The absolute value of x equals 6. I'm going to take off the absolute value sign, and I'm going to, on the other side of the equation, I'm going to put a plus, minus in front. And I get positive and negative 6. Then you can check it. The absolute value of 6 is 6. Yes. The absolute value of negative 6. Yeah, that still works. Example 6. The absolute value of x equals negative 5. Now, you have to look, before you start solving, before you take off the absolute value sign, look at the number, look at the opposite side of the equation. This is a negative 5. There's nothing that I could put inside this absolute value symbol that's going to give you a negative 5, because you can never get a negative coming out of an absolute value. So don't even bother solving. This case would be no solution. Or you could use the null symbol for that. And then, this is the kind that people have trouble with. It's really not hard, but for some reason. All right. Now, first of all, that's positive 4, so I don't really have any issues like I did in example 6. I'm going to take off the absolute value sign, and I'm going to put a plus minus in front of the other side. Now, I'm not finished here. I can't just say plus minus 4 is the answer. I haven't really solved yet. So this tells me I've got two different equations. I have one for the plus option, one for the minus option. I have a plus route and a minus route. So x minus 1 equals positive 4, and x minus 1 equals negative 4. This one is obviously 5. 5 minus 1 is 4. Don't assume that this is going to be negative 5. That's not the case. So keep, change, change. I'm going to add 1 to both sides to solve it. Negative 4 plus 1 is negative 3. Negative 3 is the other solution. And those are the two answers. It's weird to think that you could get a negative as a solution, but when you check it, it makes sense. So plugging in the 5 first to the original equation, always go back to the original on your checks. This is the absolute value of 4 equals 4. Yes, that works. The absolute value of negative 3 minus 1. Now keep, change, change. Inside the absolute value, I get negative 4 equals 4. Well, that's true because this is going to come out to be a positive. So those both work. And that's the end.